Okay, in 6.2, we are going to approximate areas with Riemann sums. The question is, how do you approximate the area when it's not a shape you know the formula for the area for? What we are actually going to do is we're going to use rectangles to estimate. Estimate with rectangles, because rectangles are much, much easier. Okay, let's go ahead and look at this graph, for example. So if I wanted to find the area under the curve from 2 to 6, I'm talking about from here to here. This is not a shape I know because of this weird curve. I don't know how to find the area of it. So to find the area of it, one way would be to try kind of split this into rectangles under here and then use that to approximate. Okay, so this is called a Riemann sum, or it's called a rectangular approximation. So if I want to find the area on 2 to 6, I'm going to use n equals subintervals and left rectangular approximations. Okay, let's look and see what that means. Okay, the first thing is it says it has to have equal subintervals. So let me start with, let's say I'm going to do 2 equal subintervals of 2 to 6. So from 2 to 6, it's 4 units. I want to divide it into equal subintervals. So I'm going to cut it in half right here. Okay, that way I have a rectangle here with a width of 2 and a rectangle here with a width of 2. So they have equal subintervals. Okay, I want to approximate the area using the rectangles that I'm going to draw here, and then I'm using the left side to approximate the rectangle, which means given this little thing right here, I'm going to use the left side to approximate the height. So I'm going to cut it off right here. And then for this little rectangular here, which is not a rectangle, I'm going to make it a rectangle by using the left height, which means I'm going to cut it off here. And this is going to be our approximation, even though you can tell it's not going to be accurate. Okay, so the area of this rectangle is going to be the base. In this case, the base is 2 times the height of this rectangle, which I can tell is going to be 2, but let's imagine this was a function called, let's call it g of x. Okay, it would be the height of the function at x equals 2, so it would be times g of 2, which happens to be 2. Okay, now I'm going to add in the area of the other rectangle. So this is my other rectangle. The base, 2. The height, because I'm using the left height, is going to be this distance right here, which is g of 4. It's also 3, but I'm going to pretend like I don't know that. Okay, and then I could substitute the values and I could add this stuff and it would give me an approximation. Okay, now you can tell that this is going to be pretty far off with only 2 rectangles. So let's see what happens if I do n equals 4. N equals 4 means I'm going to split this area into 4 rectangles. Let me erase these rectangles. Okay, so from 2 to 6, I have 4 units. And then I want to split that into 4 equal subintervals. 2 to 6, that's 4 units across here. So if I divide it by 4, I want each base to be 1 unit. So right here, 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 here. Let me draw that in. 1, 2, 3. So I have 1, 2, 3, 4 rectangles, and they all have an equal size base because I divided them equally. Okay, if I wanted to find the formula or the area of this area under the curve, and I use the left rectangular approximation, this first rectangle, the base is 1. The height is going to be based on the left side. The left side over here is going to be g of 2. Now I'm going to go to the next rectangle. The base, still 1. Let me draw this rectangle, and I'm using the left side to approximate it. So right here, I don't know exactly what that is, but it would be g of 3. Let me go to the next rectangle. Base is still 1. I'm using the left side to approximate the height, so this is going to be g of 4. Next one, base is still 1. I'm using the left side to approximate, so this height is going to be g of 5. Okay, this is a better approximation than n equals 2, but it's still going to be a little bit underestimated because I'm not counting all these little triangles in here. Okay, let's consider one more, and then we'll look at some other stuff. Okay, let's do, how about n equals 8? And now I'm going to redivide this. Or should I just imagine it? Let's just imagine it. Okay, so if n equals 8, this is 2 to 6 still. 2 to 6 is 4 units. I want to divide it into 8 equal units. So 4 divided by 8 means each one's only going to be 0.5 or half. So let me divide each of these into half. Boom, boom, boom. Okay, now each of these rectangles has a base of only half now. Okay, now I'm going to approximate it based on the left side. So I'm starting with 2. The next one also has a base of half. What am I doing? I'm going to do g of, it's in between the 2 and the 3, g of 2.5 plus 1/2. I was at 2.5, now I want to do g of 3 to approximate this height, plus 1/2. I'm going by 0.5s each time, so 2.53. This must be g of 3.5. Plus 1/2 g of 4. I'm adding 0.5, but that's corresponding to this rectangle right here. Plus 1/2 g of 4.5 plus 1/2. Okay, let's just dot, 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 dot. Plus 1/2. How far am I going up to? I'm going up to this very last rectangle, which would have a height right here of g of 5.5. Okay, now let's consider an actual function. Okay, so for this first example, this is the graph of f of x equals 4x minus 1/2 x squared. They want me to find the area on 2 to 8. Let me just draw in 2 to 8 for now. Just starting from here to here. So this area in here, using 3 sub-intervals. Okay, let me see. If this is 3 sub-intervals and I'm going from 8 to 2, what is 8 minus 2? 8 minus 2 is 6, and I want to divide it into 3 intervals. So each 2, so right here, here, and then here is how I'm going to divide it up. This time we're going to change whether we do it from the left or the right. So in this case, they're saying do the left Riemann sum, which means use the left height for your approximation. So for this first rectangle here, I'm going to use this height for this rectangle. For this next rectangle, I'm going to use the left corner as the height. And then for this one, I'm going to also use the left corner. Okay, now let me go ahead and find the area. I'm going to put it down here. Okay, now what's the width here? 2. I knew it was going to be 2 because I divided it into size 2. So 2 times, I'm using the left side, so I'm going to do f of 2. Now let me go to the next rectangle, which is this one right here. Still 2. Every time it's going to be 2 because I divided it equally. This is going to be f of, the left side of this rectangle has a height of f of 4. I need 3 rectangles because I did 3 subintervals. So 2 is the base. The height on the left is f of 6. And I do have 3 rectangles, so this makes sense. Now to get, I'm actually going to evaluate it now. Now f of 2, I can read pretty easily from the graph, so I'm going to take it from the graph. If I couldn't read it from the graph, they also gave me the equation, so I could plug 2 into the equation to get that value. But we'll use the graph since the graph is pretty clear. Okay, f of 2 is 6. F of 4, 8. F of 6 is 6 again. So then I'm going to go ahead and add this up. 12 plus 16 plus 12 is 40. So this is my approximation for the area under the curve. And again, you can tell it's not going to be super accurate because I can see all these weird little areas that are mismatched. Okay, now for B, I'm gonna do the same divisions from 2 to 8. So 2 to 8, I want 3 subintervals. From 2 to 8 is 6 units. And I'm gonna divide it into 3 subintervals, so 6, each one's gonna be 2, just like last time. So still here, still here, still here. This time I'm gonna do a right Riemann sum, which means I'm gonna use the height on the right side to approximate the rectangle. So for this rectangle here, on the right side, it goes up this high. So that's gonna be my first rectangle. For the next one, on the right side, the height is here. And then for the last rectangle, the height is here, which means that's a 0 rectangle. Okay, let's do the same method to approximate it, and we'll just compare how close they are. Okay, so the area is, the base of the rectangle is still 2. But this time when I do the height, I'm doing the height on the right side. On the right side, it's f of 4, because we started at 2. 2 spaces on the right, f of 4. Next rectangle, still a base of 2. The right side is here. This is going to be f of 6. And then that last little squashed rectangle right here, the right side is f of 8. Okay, I'm going to use the graph as long as I can. So f of 4 is 8, but I could use the equation if I couldn't read the graph clearly. F of 6 is 6. F of 8 is 0, which is why my rectangle looks squashed. So 16 plus 12 is 28. So if I use the right side, I'm getting that the area is 28. When I use the left side, I got 40. Okay, let's consider 2 other methods we might be asked to use. Okay, the next ones, we're going to use the midpoint. Oh, actually, let me tell you the abbreviations. If you're doing left, the abbreviation, you could say LRAM, right, RRAM, because that's a lot of stuff to write out. Okay, if I want to do the midpoint, if we want to abbreviate, we can call it, let's call it MRAM. Okay, I'm still going from 2 to 6. 2 to 6, no, 2 to 8. Dividing it into 3 units still, so it's still going to go by 2. So here and here. But this time I want to take the middle for my approximation. So between 2 and 4, the middle's at 3. So I'm going to go up here and make my rectangle hit right in the middle. Okay, now my next rectangle goes from 4 to 6. So the middle of 4 and 6 is 5. So that's going to be here. And then between 6 and 8 is 7. So I'm going to use that for my height. And I'm going to do my rectangles that way, which if you look at it, it really does look like a better approximation. Okay, let's go ahead and set it up and then we'll calculate it. So the area is going to be, the base is still 2. This time when I do the height, I'm doing between the 2 and the 4, so it's going to be f of 3. Okay, and then for the next rectangle, the height is f of 5. And then for the third rectangle, between 6 and 8, the height is f of 7. Okay, now f of 3, I can't get a good answer on that, so I am going to have to go to the equation this time. So what was the equation? The equation is this one. So if I plug in 3, that's 4 times 3 is 12. Half of 3 squared, 9 halves. 12 minus 9 halves. Let me write that down. 12 minus 9 halves. Actually, let me rewrite the equation here so I don't have to keep looking up. Okay, plus 2. Let me plug in 5 because, again, that point is just too hard for me to read. So 4 times 5 is 20. 5 squared is 25 divided by 2. F of 7. No, that one looks like a decimal too, so let's plug that in too. 4 times 7 is 28 minus 49 over 2. Okay, I'm going to put this in my calculator. Okay, when I put it in the calculator, I got 37 for my area that time. Okay, and if you look back at the left, right, and midpoint Riemann sums, the midpoint looks like it's the most accurate so far. Okay, one more type. We could do a trapezoidal sum. Okay, let's consider. I'm still going to go from 2 to 6. 2 to 8. Why do I keep saying 2 to 6? Okay, I'm still dividing it into 3. 1. There we go. Okay, now instead of doing rectangles, we're going to do trapezoids. Okay, so if I look at this thing right here, it's a sideways trapezoid if you think trapezoids have a direction. So I'm going to close this, and you can see there's a little trapezoid here, and it's actually pretty good coverage. Okay, this one's same. Let's make it a trapezoid. Right here, it's a trapezoid, but it's also kind of a triangle. The base here is 0. Okay, so I'm going to use the trapezoid formula to find the sum. If you forgot the area of a trapezoid, it's 1/2 height times the sum of the bases. Okay, let's try this one now. Okay, so I'm going to do 1/2. Remember, this trapezoid's kind of oriented sideways. So in this case, the height is this distance, which is the 2. Okay, now the bases of this first one is going to be this one and this one. So I'm going to do f of 2 plus f of 4. Okay, now let's go to the next trapezoid. I'm going to put it down here because I'm running out of room. Okay, the next trapezoid is this one right here. 1/2 height. The height of the trapezoid is this distance. The two bases are this one and this one, so f of 4 and f of 6. Okay, one more trapezoid. Although really it's a triangle, so you could use the triangle formula, but not always, so let's do the formula. Okay, the bases here are f of 6 and f of 8. Okay, now let me look at this real quick. Should we go with numbers? Let's go with numbers. Now, half of 2 is 1 every single time, which is going to make this a little bit easier. And the fact that I can read the graph helps too. Okay, so half of 2 is 1, so let me do f of 2 plus f of 4. F of 2 is 6, f of 4 is 8. So 6 plus 8. Okay, half of 2 is 1. Let's do f of 4 plus f of 6. F of 4 is 8. F of 6 is 6. Half of 2 is 1, f of 6 is 6, f of 8 is 0. Okay, and I'm going to go ahead and add that up, and I get that the area is 34. And just looking at it, my guess would be this would be the most accurate, although it's a little bit of an underestimate. Okay, next we're going to consider whether each of these are under or overestimates, but just glance at it and see which ones seem to be the most precise. Just looking at it, looks like trapezoidal has the least error. Midpoint seems not the worst, pretty close. When you go left or right, left and right approximation method has a lot of error on it, depending on the function. Okay, for each of those 4 methods, they're not super accurate. Some of them are better than others. But none of them are accurate. So we're going to consider which ones are underestimates versus overestimate and what the indicator for that is. So first let's consider if it's an increasing function, like, let's do this one. This is increasing. It doesn't have to be linear. I'm just doing this for the sake of my easy picture. Okay, now first I'm going to consider if I do a left rectangular approximation, and then I'll consider the right one. So if I do the left rectangular approximation method, or LRAM. Okay, if I were to draw the little rectangles here, there's a little rectangle. Here's my next little rectangle. It's going to hit on the left. And then if I add up all these little rectangles, it's going to be less than the actual area under the curve because I'm missing all these little corner estimates, these little corner areas. So if I do LRAM on an increasing function, it's going to be an underestimate. Now, if I did the right rectangular approximation method, I'm going to use the same increasing function. Let me start over here. So then I'm going to fix the right side for the height, fix the right side, fix the right side. So this is the right rectangular approximation method. For RAM, you can see that it's a little higher. If I add up the area of the rectangles, I'm gonna make an overestimate on the area. So if it's an increasing function, the area under the curve using LRAM will be an underestimate. If I use RAM, it'll be an overestimate. Let's consider a decreasing function. Doesn't have to be a line, just easier for me to draw. Okay, so if I do a left rectangular approximation method, okay, I'm fixing the left side, fixing the left, fixing the left. What's that gonna be? Over, because the rectangulars are a little bit bigger than the actual curve. If I do the right rectangular approximation method, then the right side is going to be fixed. So this little guy's pretty short, short, short. It's shorter than the curve, so it's an underestimate. If it's decreasing, LRAM will be an over, RAM will be an under. Okay, for the under overestimate of a trapezoidal, we're going to consider the concavity of the function. So I tried to draw something that was concave up. Okay, now let me think carefully if I do a trapezoidal under this thing. Let's see, I'm going like this to this. Okay, it's pretty close, but it's gonna be a teeny bit above. So a trapezoidal sum will be an overestimate if the graph's concave up. Now if the graph's concave down and I do the trapezoid, maybe something like this. That little secant corner, this little line here, is going to be below, so the trapezoidal sum would be an underestimate. For the left LRAM or the RAM, it would just depend on whether it's increasing or decreasing. It would not depend on the concavity. Okay, example 2, using Riemann sums with a table. Okay, the rate at which water is being pumped into a tank R of T is continuous, and it's increasing for 0 is less than T is less than or equal to 12 minutes. Estimate the number of gallons pumped in during the 12 minutes using, okay, first we're going to do the right Riemann sum method with 4 sub-intervals, and then we're going to determine whether that's an over or underestimate, and I'm given a table. So let's consider this here. Okay, I'm going from 0 to 12. I want 4 sub-intervals. So 0 to 12 is 12 minutes divided by 4, which means each interval is 3 minutes. Okay, so this is my first interval. This is my next interval. 6 to 9 is my next interval. 9 to 12 is my next interval. Oh, that was very ugly. Let me redraw that. First interval, second interval, third interval, fourth interval. And they're all equally spaced because it's going by 3s. Okay, now let me think about this. If I were graphing this, the width is from 0 to 3, so that's 3. Now what's the height? Be careful, this is the right Riemann sum. So if it's going from 0 to 3, the right side is the height at 3, so that's going to be the 13. Okay, now let's go to the next little rectangle. So from 3 to 6, still 3. They're equally spaced, so it should always be the same. Okay, if I'm going from 3 to 6, the height from the right side is going to be the 18. Okay, from 6 to 9, still 3. They're equal. If I'm going from 6 to 9, the right value is going to be the 23. 9 to 12, 3. What's the height? F of 12, 27, because I'm going on the right every single time. Okay, now I'm going to go ahead and evaluate that, and I'm going to get 243. Let me consider my units real quick. Okay, so I'm doing the area under the curve, so that's going to be the minutes times the gallons per minute. So the minutes are going to cancel. It's going to be 243 gallons is our estimate for the number of gallons pumped in during the first 12 minutes. Now the next question is this an over or an underestimate? Okay, let's go back up here. If it over or underestimate for a right Riemann sum depends on if it's an increasing or a decreasing function. So it says that this is an increasing function. So if it's increasing, the RRAM is going to be an overestimate. So over or under, this is an overestimate. Because R of t is increasing, and that was given information. Okay, let's do a left Riemann sum with 4 subintervals. So it's still going to be divided the same way, but this time we're using the height on the left side of each of the rectangles. So still a width of 3. If we're doing a left Riemann sum, we're using the height on the left side. So from 0 to 3, the height on the left side is going to be the 7. Okay, now I'm going from 3 to 6. The width is 3. The height now is going to be on the left, which is the 13. Plus 3, 6 to 9. Left side, 18. Plus 3 times 9 to 12, left side's 23. Okay, let me evaluate that, and I'm going to get 183 gallons. Okay, it would be an underestimate, which means in reality it's probably somewhere in between. Okay, now let's consider a midpoint Riemann sum. No, but we're only going to do 2 subintervals. So let me look at this. Okay, so from 0 to 12, I'm going to split it into 2 subintervals. So I'm really just going from 0 to 6, and then from 6 to 12. Why do I keep putting that in a weird spot? Hold on. Okay, 0 to 6, 6 to 12. Okay, midpoint. If I'm going with only 2 subintervals, I'm going from 0 to 6, so the width is 6. Now the midpoint is going to be the height in the middle of 0 and 6, which is middle of 0 and 6 is 3, so the height's going to be 13 there. Plus. Okay, the second subinterval is from 6 to 12. It's still a width of 6 because I break it into constant width. Midpoint between 6 and 12, the height is at 9 is 23. So using that method, I calculate 216 gallons. Okay, trapezoidal sum. How many intervals? 4 intervals. Okay, 4 intervals, I'm back to these ones. 0 to 3, 3 to 6, 6 to 9. Okay. How am I going to fit this all on one page? Okay, trapezoid. So I'm going to do 1/2. Remember, I'm kind of looking at it sideways like this. So the height is this distance, which is actually going to be the 3. I'm going to add the bases, which is this plus this. So from 0 to 3, on one side it's 7, on the other side it's 13. So 7 plus 13. Okay, 1/2, still 3. But now I'm going from 13 to 18, so 13 plus 18. 13 to 18, I'm going 18 to 23. And then the last interval is from 23 to 27. Okay, I'm gonna go ahead and calculate that. I get 213 gallons using the trapezoidal method.